All right, here we go. So we're near the end. Final exam is a week from, not today, a week from Wednesday, right? So there's today's meeting and then 2 more meetings in addition to today. Then the final exam on Wednesday. We meet in this room at 12 o'clock, a week from this coming Wednesday. And there's really one last task to take care of. In addition to reviewing for the final, which we can do on the last day, it's to finish this, this lab exercise, which is a big exercise. So it should, I've given you a lot of time to work on this. And basically what you need to do is write a tic-tac-toe game that runs as a console program. So it asks the user for input, the user types something in, a board, or a grid is displayed showing the user's move, and it shows the computer's response, and the user takes another move, and so on. So your program needs to detect when there's a win condition, and detect a tie condition. So either the computer can win, or the user can win, the player can win. So what we're doing in lecture is to write a program that's similar to tic-tac-toe. So Connect 4, that's what we're implementing. This is not the right place to go. Here we go. So there, the computer played first. It may be random, and if I refresh this page, maybe the player can go first. I'm not sure. Yeah, see, now the player can go first. So there's some randomness there and who gets to go first. And that's a part of the problem statement that you need to work on here. And, it's not that important that you implement this part of the problem. So I would say that, that as you start the problem, just to set that requirement aside, that there's a random decision about who goes first. Just let the player go first, or let the computer go first. Just fix it like that. And then if you have enough time at the end, you can add on this ability for the program to decide randomly whether the player goes first or the computer goes first. And by the way, this random decision about who goes first is very easy to implement. It's not hard. But it's something that you could set aside in the beginning and get everything else working first. So basically what the program does is has to display a visual of what the game board looks like. So in your program in tic-tac-toe, you would display an empty grid or a grid with a computer move in it. And now the user needs to input information. The user has to make a decision. In the case of Connect 4, the user has to pick a column. So it's column 1, column 2, all the way up to column 7. In tic-tac-toe, the user has to select a cell in the grid. So you need some way of inputting that value. You could read a row and column value and make that your user input, 2 values. Or you could number the cells 1 through 9 and have the user type in a single number. And that's how you can get the move from the user. So you would decide how you want the user to make a move. So what I'm going to do with Connect 4 is to ask the user to select a column. And then let's suppose the user selects column 3. We're going to display the board with the user symbol in the bottom row of column 3. And then after that, the computer will have the computer randomly choose another column. It could be column 3. Randomly choose one of the 7 columns and then have the computer take that move. So you see, as soon as the user makes a move, the computer makes a move right afterwards. And we're going to, just for simplicity, we're not going to have any advanced AI in the computer. The computer will simply take a random move. Okay, that's the beginning of a program. If you want to add AI, more AI than that, you can. But I would start with just getting an implementation working with a purely random move. Well, let's see what we have. This is the code we wrote last time. Look, we have a grid of size 6 by 7, so 6 rows, 7 columns. You can see these are 6 rows. That's row 1, 2, 3, 4, 5, and 6. But the way we're doing it is this would be in code. This is row 0, and all the way up to row 5. So there's row 0 through row 5. That's 6 rows. Same with columns. Is column 0 through column 6. That's 7 columns. Okay, we have to keep track of that. And so we declare the grid here, and the grid has to hold something. It's and here we declared it as holding a character, a char, which is a byte. It's an 8-bit value. And in the old days, 1 byte was good enough to store character data, because languages such as Chinese and all the other languages, Thai probably, have character sets which are large and wouldn't fit in a single byte. So that problem's been solved, but still, we still have this data type from the old days called a byte, or a char, which basically represents a byte. And so we have a function. It's a helper function here, which prints the grid. When we want to print the grid, we call print grid, and it shows what our grid looks like. So we're going to have a loop. We loop through the rows and the columns, and we print out the character that we've stored in that 2-dimensional array. So you'll do something like this with your tic-tac-toe program. You don't necessarily need a 2-dimensional array. You could use a single vector with 9 slots in it to store the moves, the state of your grid. But if you want to use a 2-dimensional array that's 3 by 3, you can do that too. So you've got some choices. And see this C out here? This is how we print the grid. And you see this loop here iterates through the columns. So for a given row, we iterate through all the columns and print out what's stored in that row. And then we print a new line, so we go to the next line. So we print the next row, and so on. So the first row that we print is row 0. So that means that'll be this one here. This will be row 0. And the last row is row 6. So when we make a move, when the user picks a move, we basically need to search downward along the column and find an available slot. Now, if the row is 100% filled, like this, well, I can't do it now, but I shouldn't be able to pick this column again because it's full. So we'll implement that as well. Get this plugged in here. I'll just take that add off the screen. There, the computer goes first. So here's our main loop. And the first thing we do here is we initialize the grid. What's going on there? I'll leave it alone. We initialize the grid. We set everything to a dot. Let's just comment this out to see where we are. We're just going to review where we are. I commented all the lines out except for these. Actually, I'll forget about this loop. I'm just going to declare a column variable and then call print grid. So we should see a grid of just dots in it. Because here we initialize the grid to all dots. Well, let's see that work. There it is. There's the dots. Now, just to keep things clean, we're going to use functions. So we want to keep the main code simple so that we can manipulate it more easily. We can manage it, grow it, change it, edit it more easily. And so this initialization code here is something that we could separate off into its own function. It's not as important to put the initialization code into its own function as print grid, because print grid is something that we're going to end up calling perhaps at different points in the program. So we want to, we don't want to copy code into different locations. But initialization is only done once. Nevertheless, it improves readability sometimes to put code that's only called once, such as initialization code, in its own function. Just call that function, just for readability purposes. So let's go ahead and do that. And I'll put that up here. I'll call it a init.
That's supposed to be an integer?
Hold on there. For init?
You have an init.
To initialize it.
Okay.
What am I doing wrong?
I just want to make.
I did something wrong there. I think it should be void. We don't need to return anything. We just call init.
Okay.
Do I have an issue?
No.
No, we're okay. Let's test it. Looks all right. So look at main now. We just call init, and then we call print grid. Well, we create a variable column. We don't need yet. All right, so that's how that's working. Now let's look at our main loop. The loop inside main. And all games have a top-level loop called the game loop. So it's very important what happens in this game loop. It runs a lot. So while true, we're making it infinite. So we'll change that later perhaps. And then we ask the user to choose a column. We input the column here. That's the reason we declared this variable there. And then we put that value in the column, row 5 of the given column. So it's not fully implemented. This is our stub code. So actually, and then we print the grid, because this is the user making a move.
In the morning, every minute counts.
Uh-oh,
Simplify
I gotta
your
do
routine
this.
with Garnier BB Cream. 1 step, 5 instant results.
Is that going to
Intone
interfere
corrects,
with?
protects, and brightens. Simplify.
There we go. So I think what I'm going to do here is make another function called player, or player move. And I'll put this business in there. So for the player to move, we have to ask the player to type in a value. And it's stored in a variable called call. And then we put an X somewhere in the grid, in the array to show that move. So now we initialize, then we print the grid, and then we want the user to make a move. So it's player move. We print the grid again, and then we print out the computer plays, but we don't do anything yet. But let's go ahead and do something. Let's, just to get it to look like what we want it to look like. So maybe the computer plays by going into, you know, say, column 1, just to see what it looks like. And we would put a 0 in there, or an O. And we print the grid again. And then we prompt the user to play again. But let's make this symmetric. We have a function for having the player move. Let's create a function that has the computer move, just to keep things readable. And I'm just going to copy that. So the computer is going to move. And this is our computer move. It simply does this. The computer simply puts an O into row 5, column 1, which is the 6th row in the 2nd column. So we need to call that.
There's a spell.
Thank you. C in
No, you're right.
No, you're fine.
is okay. We're just going to say the computer's playing now. So choose a column. Well, I don't want to pick 1. I want to pick, yeah, I'll pick 1 because 1 is column 0, I think. So yeah, we went into column 0 and then the computer goes into column 2, or column 1. You know, we have to translate between player numbering, player counting, and computer counting. All right. So we have a couple of different things we could do next. I think what we could do is let's have the player, let's start stacking the X's rather than just sliding down to the bottom row. Let's search downward and put an X where it needs to go. All right. So we input a column. We'll need to do that in a loop. I'll start with an infinite loop. Because if the player doesn't enter a valid move, then we'll prompt the player to move again. So we're going to ask the player to choose a column. We input that column. And then we'll search for an available row. So I'm going to call that R. Int R, for R equals 0, R is less than 6 or 6 rows, plus plus R. So if grid of R call, something's wrong?
And then
You
call
want to use
-1.
call -1 because the user's going to input starting at 1.
Oh, that's right. Thank you very much. Let's just do it like this. We'll subtract 1 from column. So, and we'll do it like this. We can look for bad input, like if column is less than 0, you know, we could do that. All right, but that's little cleanup stuff we can do later. So if we want to add that later, we will. We'll assume the user will enter in a number between 1 and 7. So when we subtract 1, we'll get a value between and including 0 to 6. So if grid R column equals, so if it's open, then we can play there.
Yeah.
But I think what I want to do is look at the next row. If the next, I got to think how to do this. How do we do this? So let's find. I'll do it like this. I'm just going to think here. I can't think out loud all the time. So I'm going to create a row, set it to -1. And if we find dot, then we'll set row equal to R. So as soon as we hit a row that doesn't have a dot, then we no longer set row to R anymore. That's one way to do it. I didn't do it like this before. That's what came into my head. Any other suggestions? Okay with that? All right. I know I didn't do it this way last time, but this is what's coming out. So what happens if row is -1, then we didn't make a move. So I need to tell the calling code that we didn't make a move. So I'll return false. So I better return a bool here. So while player move equals false. That's too fancy, isn't it? That will do it. That'll keep calling player move until it returns true. That's hard to read, isn't it? I'll leave it like that and then we'll fix it. I'll make it more readable in a minute. Okay, so let's set that aside for the moment, whether that the user enters an invalid column. So once we have the row and the column, then we just set it. So this is the row. This is the column. Oh, we already subtracted 1.
Yeah, it's just called.
So we've got to take that one out. And then we return true.
How do you get your loop to stop?
Oh, wait a minute, what's going on? Oh, here, if row is -1, we don't want to return false. Oh, I totally messed up here. We're going to continue the loop. We don't need to return a bool. We're just going to keep asking the user here. So sorry, I got that wrong. Sorry about that. We're not returning anything here. So we just call this once, and the player move will loop itself. The player move will check for a valid column. So, well, we could do it like this. How about this? Clean this up a little. Here's the row and the column. And then actually, that doesn't matter. I think I'll leave it like that. Oh, I see. If we get to the, so let's see, while row equals -1. So we set it to -1, we say choose a column. We subtract 1 from the columns. We set row here, but if we never find if the very first row has got an X or an O in it, we can't move there, then we never do this assignment, which means that that row remains at -1. And that's not going to work. Sorry, I'm really, thinking this out here. We're going to have to do this. So we we leave row at -1, and if row is not equal to -1, then we can make the move. I think that logic will work. Sorry, kind of went a little screwy here, going around in circles. I think that's good. Let's test it out. Use of undeclared identifier row, that's in line 27.
Declared row.
Well, row is -1. Oh yeah, that's going to have to.
Just need an int row.
I didn't like this solution anyway. While true, if row is not -1, and then we break, or we could return. There we go. Choose a column. So not 2, I'll choose 3. So the computer always plays in column 2. Choose a column 3. See, it's stacking now. See that? When we get to the top, see it, now we're stuck in that loop. So I can do the next column. There we go. See it? Now we're okay. We can even play on top of the computer. Because the computer is always placing the O in the same slot, even though it's an illegal move. It looks like we got that. So, it's just what do we want to do next? We could write the code that checks for ties. We could write the code that checks for a player win. Because we can force a player win. This is a good way to force a player win. We can get a player win very quickly now.
Yeah.
So it's good to test. This is a good point to implement the code that tests the player win, because we can just get to that point quickly. All right, so let's do that. Let's write a function that tests for the player win. So bool player wins. So it's going to return true or false. Let's just return true. You see how I'm stubbing these functions out? All right, we want to break it down into pieces. So, am I going too fast? Did you want to look at this logic in here a little bit more, or you want to move on? Move on, right? Yeah. So after the player moves, we're going to print the grid to show that the players move. And if the player wins, then we'll congratulate the player and terminate. Notice that I'm doing that outside of the player wins function. So printing, the fact that the player wins is it's better to do it outside of this player wins function to keep that player wins function more narrowly scoped in terms of its responsibility. It just returns true or false. It's not going to print anything. It's just going to say yes or no. Is the player in a win state? So if the player wins, we see out this. We can either return here or break. We'll just break. All right, let's test that. So the player will win after the first move. Choose a column. It doesn't matter what we choose, we're going to win. Player wins. There we go. So now let's remove the stub code with an implementation. How do we check for a player win? Well, we have to have 4 in a column, or 4 in a row, or 4 in a diagonal. And there's 2 different diagonal directions. So we got to check a lot. So let's check for the we'll check for the 4 in a row first. So to check for 4 in a row, you know, we have to check, are these 4 X's? No. 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 Oh, that's all the possible rows. That's all the possible wins you can get out of the top row. Now let's go to the next row and repeat the same sequence of tests. Are these 4 X's? No. Are these 4 X's? Do you see the repetition there? So basically do an exhaustive check. We just look everywhere. The board is small enough that we can do an exhaustive search. If it was large and we needed to find 4 things in a row, we might choose a different algorithm. But because the board is small, we don't have to get complicated with a more efficient algorithm. So the outer, think about it, what's the process I just described was I work within a row, and then I go to the next row. So the outer loop is going to be to iterate through the rows. So we'll do for integer r equals 0, r less than 6, plus plus r. So once we're in a given row, so we're in row R now. At this point, we're out of the cursor, we're in row R. R could be 0, R could be 5, or anywhere in between. So in this row R, we have to check how many things? Well, this is 1, and then 2, 3, and 4. I have to do 4 checks. So if grid of R0, or O rather, no, R0, what am I doing? If grid of R0 equals X, or grid R1, not or, sorry, it's got to be and. It has to be and grid R1 equals X, and just go through there. Notice I started this process without fully thinking where I was headed, but as I type it out, I'm realizing where we need to go in detail.
You forgot your X on the 3rd grid.
I forgot something?
Your X right there.
Yeah, equals X. 1, 2, 3, and this is the 4th one.
Don't we also need to connect it so that, oh, no, never mind.
Return true.
So we got to check the other ones too, right? So we could do it like this. So I didn't mean to ignore you over there. You had a suggestion of what to do next, right?
No, I didn't realize that you had already connected the 2. You were checking each individual piece.
Yeah. So we can write a loop I'm doing it manually. See this?
Yeah.
Just bumping things up, and then I have a big OR right there. Now, I'm doing this manually, but we could put this in a loop, right? Because what I'm doing manually, I could just do in a loop. But you know, it's a readability issue. What's easier for you to read? I can add a loop in there. I know last quarter I did it with a loop, okay? This is just a lot of code here, but you know, it's a very small program, and it's not a big deal. We're not like wasting, you know, space in the computer or anything like that. The main idea here is that this should be readable and the logic should make sense to us. Does that make sense?
Yeah.
It's easy to understand, but we could collapse this. Instead of 4 separate lines here, we could have a loop. And then here, we would start at, the inner loop would be like I. We've got I equals 0 to 4, because we have to check 4 rows. I'm sorry, 4 column start points. So this would be 0 plus I, 1 plus I, 2 plus I, 3 plus I. Then I would go from 0 to 3. And we would get the same thing, see? 0 to 3, that's 0, this is 0 plus I, you know, if I were 3, then we would get 3 there. 0 plus I, you know, and what would that be? That would be 3, so 3 plus 3 is 6. That would give us the same test. But it would, we could delete 3 lines and replace it with a for loop. But we'd have to add a variable in here. Do you think that would make it more readable, or do you like it like this? What's easier for you to understand? Who likes it like this? How many people want to introduce the loop? I think the loop has an edge here. The loop has an edge. It does reduce the amount of code. So let's take a look at this. Let's do the loop. Anyway, it's good to see how to do it anyway. So we start with I. I has to go to 0 through 3. And this is going to be, this is plus I, plus I. I'm going to have to stretch the window out. Plus I, plus I. Now this is going to have to be in a big if statement. So if this is true, if all of these, if these 4 neighboring cells have an X, then the player wins. And we return true. See that? Then we can get rid of these. Is that easier to read? For some of you, this is easier to read, or you thought it was easier to read when you made that decision to raise your hand. And for others of you, this is harder to read. I don't know. It's subjective, right? It's up to you. You decide how you want to code this out. So you do it the way that you think is easier to read. That's it. Now, you could see here, we do these things here. Look at this first item here. That's a 0, a 1, a 2, and a 3. Rather than stringing this whole expression out, we could have another loop. And we can have like, we can have a loop that search for something that's not an X. Well, no, we'll need to set a variable and say, you know, the player wins. and then we check, go into a loop to check to see if, you know, this value, say we have another loop where 0 is now j, where grid of r j plus 1 is not x. If grid of j plus I is not x, then we set player wins to false. We initialize player wins to true. We could do that. So we could shorten this up. It doesn't have to be long like that. We can shorten it up with another loop. Do you think that would make it more readable? We're not sure, right? If we do it, we might know. Should we do it, or should we skip it? We don't know. Who wants to see it? Anybody want to see it? We only have so much time to get the job done, right? There's a release date on this game, so we got to get this thing done. So we can come back to this, but I got to tell you that last quarter, I did replace that with a loop. And basically, now you've got a for loop with a for loop and another for loop, and the code just started deteriorating. I mean, got 3, 4 loops, one within the next. It just was not readable. I mean, it was pretty, to me, it was obvious. I didn't ask for a vote on that one. But so if we do that, you know, it's just going to get so much harder to read. But maybe not. Maybe for some of you, it'll be easier to read. But we're not going to go down that path. So anyway, this returns true if we get 4 in a row. And if we break out of this, if we never hit this return statement, it means we checked every row, which we're assured of doing here. And then we need to return false, okay? So let's see if that works. Oh, computer move. Player wins. So that's all set. We just have to build this thing. Let's run it. Okay. Choose, let's do 3, 4, 5, 6, player wins. Look at that. 4, 5, 6, 7, player wins. Well, we didn't check the other rows, but I think that's good enough. So we got that working. All right.
There's no way you can check with.
Well, we got to check more than that, right?
Check that.
We just checked the.
You checked one condition.
Check the horizontal. Check for horizontal win.
Which is what you did.
Now we'll check for a vertical win. And I'm just going to go with the hunch that it's really similar. A vertical win. So a vertical win means we're going to check, let's think about it. We're going to range across the columns, okay? For column 0, we're going to check whether the mark in rows 0, 1, 2, and 3 are x's. And we're going to do that all the way down till we hit the bottom. So that's 3 checks. We're going to start at row 0 and go down 4, looking for 4 x's in a row. I'm going to start at row 1, go down 4 in a row. And the last place is we're going to start in row 2, the 3rd row. All right, so the outer loop is going to be a column loop.
Yeah.
And there are, I'm just going to assume that that's a 5 without thinking about it. Now I better go back and check my thinking.
There are more columns than that.
Huh?
There's 7 columns.
There are 7 columns. I got it wrong. I knew it had to be changed. I got that part right. All right, so, and now this I will be the start point in the row. And we only want to go down to 3 or 2. We're going to stop at row 2. So if grid of, let's see, this should be the I, right?
Yes.
So this should be 0 plus I and this is column C. And this should be grid of 1 plus I, and this is column C.
Be quicker just to delete the first brace and then remove this with the C behind it.
I'm going to continue with this. It's easier. And so I'm going to get this out with a C. Just get me if I'm doing this wrong. This should be 3 plus I. And this should be what?
C.
C. All right, that checks it. What do you think? We did it? We don't need 2 of those. All right, let's test it. All right, we'll go down column 1 to begin with. One more and I win. It's a win. All right, now let's check this. Watch this. Let's go down column 2. One more and I should win. Win. Looks like it's working. Maybe we should check the last column, which is what, column 7? Win. Okay. Last column to get there. All right, so we have, we still need another check. We need to check the diagonals. There's a lot of work here. So let's think about it. We're going to need to iterate through the columns and the rows, something like that. Let's think about, yeah, we're going to need to iterate through columns and rows, aren't we? So we're going to check, let's check the diagonal that goes this way first, and then we'll check the diagonal that goes that way. So this is the sort of the negative sloping diagonal. And if we start here, look, we have this one, this one, this one, this one. Let's fix the row. Let's suppose we stay in row 0. I can see it happening already. So I want to, so this is check the, I can already see where we're headed. Because I did this before, so it's easier. So we're going to start with row 0, and we're going to go across and stop at row something. What row would we stop at? If we go down like this, if we check this one, this one, this one, this one, that means that starts at row 0. If we start at row 1, we would have hit here. If we started at row 2, we would hit here. So we can only go to row 2. So the rows have to be less than 3.
4.
That's the row that we're starting. We're going down the diagonal like this, see? That's this one, and then we'll check this one, and this one, and this one, and so on. And we can only do it up to this row, because any diagonal going down, there's no diagonals for these rows that go down, right? So we've got to stop at row 3. All right. So what do we do for each row? For this row, we have to check these 4 items. And then we increment the columns, and we go to the next column, and then we check for these. See that?
R plus 0, R plus 1.
And then we go to the next one, and which is, so this, the first column ends here. The diagonal ends here. The second column ends there. And the third column ends here. And the fourth column, which is column 3, ends there. So that column is that one right there. That's column 3. Looks like a 4.
Yeah.
Train yourself. That's a 3. Okay, so we got to go from 0 to 3. Oops. All right, for each of these row column positions, so what we need to do is check to see that we have 4 X's. So it's going to look like this. It's going to copy that. All right, so we're not in row 0. We're in row R. And and we're in column C, right? That's the starting position. So we're iterating across the starting positions for the diagonals. And then the next one in the diagonal would be R plus 1 and C plus 1. Does that make sense?
Yeah.
And then this would be R plus 2 and C plus 2. And the next one is R plus 3 and C plus 3. Let's change the comments. Check for a negative sloping diagonal wind. Now we got to test this thing.
I don't think you can test it without changing the computer movement.
No, because we're only getting X's. Oh yeah.
Because you're going to build a winning condition before ever getting the
Well,
diagonal.
I think we might be able to do it. Let me try it.
You'd have to stack on top of the.
Yeah, I think I can do it like this, right?
You're going to get 4.
Wait, are you right? Is that right? I can't do it without getting I can't get this?
If you go on top of O.
4, right?
You should be able to do it.
You'll still have 4.
Wait, tell me what column to pick.
2.
2.
2?
Yeah.
2?
Yeah.
Mhm.
Oh,
One
it's
more
not.
time.
One more time. Yeah.
That's it?
That's the only way
I didn't
to
even
test
see
it,
that. Well, luckily we put the O in the somewhere.
Yeah.
So that's working. We got the diagonal check to work. Thank you for that. You guys are way faster than I am. So now we got to check for the positive sloping diagonal wind. It's getting to be boring, right? Positive sloping diagonal wind.
Let's just change the minuses.
How are we going to do that? Well,
Change the computers and flip for one turn.
yeah. Well, the first column that's acceptable is this column 4 here, right? Or column 3. And because we got to go this way, right? So we'll hit down there. So it's the same rows. You know, row 1. Row 0, 1, and 2. So we're going to scan across rows 0, 1, and 2. But this time we're going to scan across columns 3, 4, 5, and 6. And then we have to change, instead of +1 on the columns, we're going to make it -1. Okay. All right, so the rows are the same. And the columns, we start at, what did I say? We start at 3.
3 and go to 7.
And
Or less than 7.
stop at less than 7. I'm just trusting you on that one. That's what it needs to be, right? Okay. All right, so now we check grid of RC, that's the first slot, so that's unchanged. That's good. Then we're going to see if in the next row, oh, look how easy this is. We just subtract 1 there. So we go to the left instead of to the right. What do you think about that?
But you need to change the rows to minuses too.
Change what?
The rows to minuses too.
Change what to minus
The
2?
rows.
No, no, because that would go, we would have negative rows, because the rows starting at 0 here.
Okay.
Yeah. See, the rows start at 0 and go down. It's the same thing. Now we're starting over here, we're going to go this way, see? And then the next one. So I think that does everything. That gets every one. It's no diagonal that we miss. Right? Like this diagonal here. See this one? 1, 2, 3, 4. See the diagonal that ends there? The downsloping diagonal that ends there? It starts there, right? Which is row 3, column 6. And we hit that. So I think we're all right.
Okay.
But we need better test code. The computer plays, we're going to move the computer to a new slot, and we'll put him in column, column 3? I'm just guessing at that. So, I get that?
3 and 4.
Got it. So there's a negative sloping column.
Positive.
I think we got everything. This is the entire check. This determines whether the player wins.
Copy that over for the computer.
Huh?
Just copy that over for the computer.
Well, that's the thing. I knew where we were headed here. Are we going to copy all that code?
You need to change the x's to o's.
All we got to do is change an x to an o. Do you think, wouldn't it be better just to make a function instead of having to copy all the code? Let's have a variable, which is of type char, and it's either equal to x or o. So we're going to change the code. So it'll look like instead of player wins,
Win.
we're going to say, well, player wins. The user, right? Calling it the player. Just call it wins. We'll pass in a char, and we'll call it, I don't want to call it a C for char. It's what, S for symbol? Like an X or an O? So does symbol S win or not? So now what we got to do is check not for an X, but for an S. Now let's make this really fast. And there's a faster way to do it, but I'm going to just do it like this. That should be, what was that again? S. Whoops. 3, change that, S. All right, I'll make this as fast as I can. There is a faster way to do this. A VI Pro would be able to would have this done already. It would be a substitute command, but it's hard for me to remember how to do it. And just in case it would take me too long to figure it out, I'm just going to do it manually. All right, there we go. Oh, that's not going to work. When we call this thing, we got to pass in. We got to pass in the character here. If wins, X. Player wins. Let's check that. Whoops. Player wins. That works. All right, now we're almost done, really. It's incredible. Do you want to just pack it in there and get it done in 10 minutes, or do you want to take a break? How many people want to get it done? All right, let's get it done. Now we got to make the computer has to move. And oh, we got to check for the tie. We'll try to get it done. Oh, I think it'll be easy to get it done. Yeah. So we make the computer has to move. So what we need to do is just to pick a random column. All right. So, and I'm going to do it like this. I already thought about the problem. I was explaining it to a student in lab last week. So with that experience, I have a memory to work from. So while true, and we're going to do this. We're going to pick a random number. So a random column. Rand mod what? 7. Yeah, good. So it'll give us a random number between and including 0 to 6. Now, whoops, sorry. If grid of 0 C equals a dot, then we're good to go. If we know that that's the check, is there at least one row, one slot available in the column? You just check the top row. You know, if that's a dot, then we might, we can play that column. So how do we play the column? Then we have to have that loop for integer r equals 1. We already checked for row 0. R less than, what is it? 7? No, 6?
Yeah.
6. And plus R. If grid of R no, I don't like it like this. I changed my mind.
You got to 0 and change it.
I changed my mind. Let me show you where I'm going. If grid R plus 1 C does not equal a dot, then I can play there. I should play. If the next row from where I am, I'm in row R, if the next row doesn't have a dot, I got to play in row R. And I know this will work because we checked for the first one already here. So grid of RC gets an O. And we return. We return from inside the loop. There's too many loops there. If I hit break, then we're going to go to this while loop here. Then I'll have to introduce another variable, which is, did we find a spot or not? So I don't want to do that, so I'm just going to return. So there the computer moves. Let's see if that works. Pick a column. So 1, 2, 3, 6. Look at that. 4. I win. Now we got to see if the computer wins. We got to check for that. So here, 1, 2, 3, 4. We check to see if the computer wins. If wins O, then the computer wins. All right, let's see if we can get the computer to win. So I'll do 1, 2, 3, 5, 6, 7, and 7, 6, 5, and 6. Trying to lose, trying my best.
4, 5.
No, not
Seven.
5. Ay, ay, ay. Can I play? 7. Yeah, thank you, thank you.
Yay.
Finally.
Good job.
How did the computer win? Oh, in column 1. See?
Wait, huh?
Now, we got to check for a tie. The tie is very, very easy. Very easy.
No one wins.
Watch this. We're going to get done so fast because the tie is so easy. If tie, then we print cout tie. Oops. Look at how easy it is to check a tie. You should already be thinking about how to do it. And we're going to check for the tie before a win. Print grid. So if tie, tie. We're going to implement tie. How? Why am I saying tie is easy?
Here's some moves.
All you have to do is check and make sure you don't have any empty spots left.
How do you check to see? Well, we know it's going to be a loop. How do we check that no spots are available? What's the fastest, sturdiest, quickest way to do it?
Iterate.
Is there 7 columns?
Yes.
Yeah.
Well, if it's a tie, then the top row's got to be filled. So we're going to check grid of 0, C. What are we going to check? If that's not, look at this.
Equal to a period.
If it's not a dot, then there's still another move. Look at that. This is like from one of your exams.
No, because it is a dot.
Otherwise, it's a tie. If it's not a dot, oh, did I get that wrong?
Is
So
it?
you'd want it.
If it is a dot, I got it wrong. If it is a dot, then there's a space that you could, that player, the computer or the player can move in.
You need an int C though.
Huh?
You need an int in front of that C in the for loop.
Thank you. Thanks. That's great. You guys have gotten really sharp eyes now. Look, this is it. Oh, if tie. There it is. Gonna call the function. Right, we're right there. We are so right there. Look at this.
You're not going to be able to get.
We gotta make a tie.
There's no way it can tie because it's going to do the same random numbers every time.
Well, we just have to block ourselves and.
Going for right now.
Oh my God.
You're going to win no
Try
matter
seven.
what.
I better play 2,
Random number.
and then I'll play.
You can do 1 again.
Yeah.
What should I play?
Play 1.
1,
1. Yeah, tell me what to play.
2.
Do 4.
4.
No,
No,
4
don't-
wins.
don't
Wait.
do four.
No, don't do 4.
You
Do
don't wanna
5.
win.
5.
Yeah, make it 5.
Next.
7.
7.
Two.
2.
Finish off the
Yeah.
What's next?
6.
Do 5.
5.
5 again.
5.
No, do 3.
Wait a minute. 5 or 3?
I was thinking 5.
Doesn't matter, right? Next one.
Do 3.
3.
Do 3.
Well, cause it could have a diagonal.
Yeah.
instead of a
6?
diagonal.
Maybe 7.
6 again? No. Yeah, 6 again, right?
Yeah.
I'm not paying attention now. Tell me where to play.
7.
7?
No.
Yes.
Finish off the column. We should have started
No, 3.
3?
3 off.
6.
6?
No, not 6. No.
You
Actually, yeah, that's the only
have
one.
to say 6.
Gotta play a 6.
You-
Oh no! Oh no! Oh no! Oh no! Oh no! We don't have time.
Implement the random number
Huh?
seed to take care of that.
Let's just go on faith that we got the problem.